What is the cardinality of AB?
The infinite, sir.
So if I ask you, so because this is a real line, right? This is a real line. AB is a over real line, and any interval, the cardinality of the any interval over AB, I mean AB, is actually equal to the cardinality over real line, right? So in a say, real line has nice this property that you take any interval, the cardinality of that interval is nothing but the equal to the cardinality of the whole R. Okay. So 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 therefore, now if you use the definition, the what we are discussing the earlier examples, uh, that so therefore the cardinality of this is cardinality of R, and cardinality R is an infinite. I mean, it's uncountable thing in the convention. It is the cardinality of continuum, which is near to the power lf naught. Everything is fine. Now, how you choose a point? I mean, what will be the probability of choosing a point from AB? What will be the probability of choosing a point from AB? Right? You try with the definition. What we are relative frequency definition? What will be the answer? Anyone? So as you told, as somebody told that the relative the cardinal this is infinity, the this thing. Now, what is the choosing a point? So you are choosing a point, and your this AB, the omega space has infinite number of points. So what will be the probability of choosing a point?
And it will be zero, sir.
Sorry,
It will be zero.
it will be zero because something anything by infinity is sorry anything. So anything, I mean, suppose any real number by infinity is always zero, right? Correct?
Yes, sir.
Yes, sir. So you understand. So anything, because you are choosing a point, that's a one point you are choosing from an interval, and then you are getting the probability will get zero. So that means you cannot choose a point from an interval, right? Or choosing a point from an interval, the probability is zero. Correct? But that is not believable, correct? I mean, you can always choose a point from an interval, right? I mean,
Yes, sir. Then
yeah. So
yes, sir. Then
you cannot choose a. I mean, you do it with the relative frequency definition. If you go with the relative frequency definition, then the choosing a point from an interval will always come as zero. Correct? That means you are not been able to choose a point from an interval. True. But that's not practical, right? That's not the real case. I mean, then you can, I mean, from any interval, you can always, I mean, for example, if you consider the interval uh, uh, 0, 1, the half is always there, one third is there. I mean, in a case that 1 by n is always there, but this definition gives you the choosing half from the 0, 1 interval is 0, right? Choosing half from the zero. So therefore, there is some problem in the relative. So therefore, there is a problem in the relative frequency definition, or or uh, or the way we were defining, because for the finite set, that's pretty good. There is no problem. No, no, but I mean, with this example, you see there is you will always get zero because it's by infinity. So how to come? I mean, the question is how to come around it. How to come around it. Okay? So So how we go about it? That choosing a point, because the relative frequency definition what we are discussing, it giving us some travel, it giving us some travel of choosing a point from this thing, because R is infinite, the it's uncountable, and so any interval you take, the cardinality is infinite. So now the question is how to overcome these difficulties, how to come around. Okay, is it okay? Hello, anyone, any idea? Hello.
No, sir.
Okay, we'll discuss this. So today our class is till 12, right? So we'll have a 10-15 minutes break and we'll resume the discussion again. Okay. Okay? Hello.
Okay, sir.
Yeah. I keep this. I keep these things. I just make the video off. It will the line will be on. So you also take a break. So 10-15 minutes we start again. Okay. Around 11, let's say, or 11:05. Okay. So we'll start again. Okay. Okay. Is it fine?
Okay, sir.
Yeah.
Yes, sir. Yes, sir.
Hmm. So Am I audible? Is it audible? Am I audible? Hello.
Sir.
Am I audible?
Yes, sir.
Okay. Okay. So what we are discussing, the how to come around this problem. Okay? How to come around this problem. So in any mathematical modeling, you try to define a unified theory which will take care of of the the whole thing, right? I mean, it's not that you define certain way, one part works and another part fails. So you try to make a unified theory so that where everything works perfectly. So the definition of relative frequency actually fails when you have this type of problem. And similarly, another example is decaying of a radioactive particle uh, uh, in certain time, because the decaying will be also uh, uh, I mean, in the interactive particle system, I mean, suppose something decays, radioactive particle decays continuous, right? And it comes to a stability now. So this type of example where you have infinite cardinality things, so we have to look for something else. Okay. Now, how to do go around it? So yeah. So uh, yeah. So one thing you notice that so the cardinality of an interval is infinite. But if I consider this interval, okay, so where R A B, what about this length of the interval?
B minus A, sir.
Yeah, B minus. And this is a finite quantity, right? This is finite quantity, correct?
Yes, yes, sir.
B minus A is a finite quantity, so there is no issue. So uh, and suppose you consider a point some C here, okay, C here, and you consider a neighborhood with epsilon this thing. So this is this point is C plus epsilon, and this point is C minus epsilon, right? Correct. And uh, if you consider the point C in some interval here, I mean, you can have C is a point in A. Okay, so A is which is a subset of interval AB. Okay? Uh, which is a subset of interval AB, and you can so C is also contained in certain interval. I mean, if I consider a small interval, right, uh, this way, and mm, mm, uh, so C is a point in A, and this thing, and naturally we can have something like A and divided by B minus A, right? I mean, B minus A is the my if I consider my capital A is AB, this interval, then then this quantity is pretty well defined. There is no issue with that, right? Hello.
Yes, sir.
So so you see, I mean, if we considering so what we have tricked here into, instead of seeing the cardinality of the set, what we are saying is the length of the set, length of the interval. And in any case, AB are two finite thing. I mean, if you consider that A is something, so to finite things, then you can always define B minus A. I mean, there is no issue with that, right? I mean, B, it is always a well defined B minus. So if you have uh, and so initially you have a problem, but the moment I define the length of the interval, I can circumvent that problem. I mean, now the choosing of a point C from the interval AB, uh, instead of evaluating it over the AB, I mean, instead of evaluating the whole thing by considering the cardinality of AB, I just consider the length of the interval, length of AB, that is B minus A, and just simply do the things in this way, and I just have no issue with it. Correct? I just have no issue with it. I just have simply just have has no issue. So so this length of the interval, therefore, for over real line, and so therefore here the measure theory comes, or the things are introduced, right? Because in the simplest term, the length of the interval is length of an interval. So if you have a length of an interval, so in a sense, it's the size of the interval, or it's the measure of the interval, right? So if you have, so the A minus B, I mean, this in sorry, I just, so I'm audible, right? Hello.
Yes, sir.
So, so this is, I can write it as B minus. Okay. The moment, and it is for over any real number or any interval, it can be done. So and basically this is it is also it's called the measure of a interval. In fact, this type of thing is called the Lebesgue measure. In fact, this type of thing is called the Lebesgue. So so yeah. Okay. So so now how to do the sigma algebra, everything over R will gradually proceed. I mean, there are certain convention. I think you people has no convention over. So convention. So sometimes this R bar is is R union minus infinity to plus infinity. Okay. So this is a notation that R bar you define this. Now hmm, now some convention is what is minus of infinity. Okay. So this is minus of path plus infinity is nothing but the minus infinity, right? And what about minus of infinity? What is this? Sorry.
Plus infinity. Plus infinity.
Plus infinity. And what about a? A belongs to any real number, okay? So what about a plus infinity? Or a plus
Infinity.
infinity. And similarly, infinity plus a. So a plus infinity equal to infinity, infinity plus a equal to infinity. So similarly, if you have, I mean, a belongs to R, what about a minus infinity? This is
Minus infinity, sir.
this will be minus infinity. Similarly, minus infinity plus a is also minus. So okay. So I mean, yeah, and similarly, suppose I have